Assalamualaikum, my name is SAIDATINA HANAN binti AZIZ, and today I will be explaining about the meaning of differentiation and the technique of differentiation. Differentiation is the process of finding the derivative of a function. In simple words, it tells us how fast something is changing. Mathematically, if we have a function y equal to fx, the derivative written as dy over dx or f prime x show the rate of change of y with respect to x. Now, I would like to talk about some technique of differentiation, or in other words, the method we use to find derivative. The first and most basic technique is the power rule. If we have a function like x to the power of n, we just bring the power down and reduce it by 1. For example, the derivative of x cubed is 3x squared. Next, we have the constants rule. If we differentiate a constant like 5 or 6, the result is always 0 because constants don't change. Then, there is the constants multiple rule. If there is a number in front of a function, we just keep it there. For example, the derivative of 5x squared is 5 times 2x equal to 10x. We also have the sum and difference rule, which means we can differentiate each term separately. If you have fx equal to x squared plus 3x, just do one by one. The derivative is 2x plus 3. Other than that, there is 3 important techniques in differentiation that help us differentiate more complex functions. Firstly, product rule. Product rule is used when two functions are multiplied together. The rules say, differentiate the first function, keep the second, then keep the first function and differentiate the second. Secondly, the quotient rule is used when one function is divided by another. The rules say, differentiate the top, multiply with the bottom, minus top times the derivative of the bottom, all over the bottom square. Lastly, the chain rule is used when a function is inside another function. We call this a composite function. First step, we differentiate the outer function but keep the inner function unchanged. Then we multiply by the derivative of the inner function. That's all for me.
Assalamualaikum and hi. My name is AMANINA NABILA binti ZIZAKI. I am presenting a solution of question number 2. First, we need to know what formula that can be used for solving this question. We can use this method and also this. But this method usually used for multiplication question. But for this method, we usually use for division question. To solve a question number 2a, we need to know what a method that's suitable for this question. So we can see 2a, this is a division question. So the method that's suitable for to use it is method number 2. We need to know what is u and what is v. So for the upper is a u and for the down is v. After that, we need to differentiate one by one. To differentiate for u, so we know that u is this. So we need to find a u prime. We differentiate this question and we get this. Also the same way we do for v. This is original v and this is v prime that we already differentiate, and this is the answer. So we need to convert all of this in this method. Vu prime minus uv prime division by v square. V is ln x plus 1 minus 8 multiply with 3 cos 3x minus u sin 3x. V prime is 1 x plus 1 divided v square ln x plus 1 minus 8. After I convert all of this, and I can factorize anymore. So this is a last answer. This is a final answer for 2A. For question number 2B, also use the same way. First, we need to know what method is suitable for this question. We see that method number 1 is suitable for use it. We need to know what is U and what is V. After we know that, we need to differentiate that. First, this is a U, and after we differentiate that, we get a U prime. Also the same, this is a V, and after we differentiate that, we can get a V prime. We convert all of this in this method. VU prime plus UV prime. V is cos 2x 3 multiply with U prime is 4x 3 plus x 4. That is a V prime negative 6 cos 2x square sine 2x, and we will get 4x 3 cos 2x 3 minus 6x 4 cos 2x square sine 2x. So this is a final answer. Thank you.
Assalamualaikum and hi, my name is AFRINA INSYIRAH binti SUHAIMI, and I'm going to explain question 3. Given y to the power of 4 equal to tangent of x square plus y square plus e to the power of xy, find dy dx by using implicate differentiation. First step, we're going to differentiate the left hand side. The derivative of y to the power of 4 is 4 times y cubed times dy dx. This is because we apply the power rule and then multiply by dy dx, since y is a function of x. Now we move to the right hand side. The first term is tangent of x square plus y square. The derivative of tangent is secant square, so we say secant square of the quantity x square plus y square times the derivative of x square plus y square. Now derivative of x square plus y square going to be 2x plus 2y times dy dx. All together this part will become secant square of x square plus y square times 2x plus 2y times dy dx. I'm gonna expand this part, so it will become 2x secant square times x square plus y square plus 2y secant square times of x square plus y square times dy dx. Next, we differentiate the second term, which is x to the power of x times y. The derivative of e to a function is itself times the derivative of the exponent. So we say e to the power of xy times the derivative of xy. The differentiate of xy, we use the product rule. The derivative of xy is x times dy dx plus y. So this term will become x to the xy times y plus x times dy dx. I'm gonna expand this part, so it will become y times e to the xy plus x times e to the xy times dy dx. Now putting the entire differentiated equation together, we say 4y cubed times dy dx equal to 2x secant square of x square plus y square plus 2y secant square x square plus y square times dy dx. plus x times e to the xy times dy dx plus y times e to the xy. Now, we will bring all the dy dx terms to the left hand side and the other terms to the right. So the equation will become 4y cubed times dy dx minus 2y second square of x square plus y square minus x square to the xy times dy dx equals to 2x second square of x square plus y square plus y times e out to the xy. Now we gonna factor dy dx on the left hand side. That give us dy dx open parenthesis 4y cubed minus 2y second square of x square plus y square minus x times e to the xy close parenthesis equals to 2x second square of x square plus y square plus y times e to the xy. Finally, we divide both sides by expression in parentheses to isolate dy dx by itself. So the final answer will become dy dx equals to 2x second square of x square plus y square plus y times e to the xy over 4y cubed minus 2y second square of x square plus y square minus x times e to the xy. That's all from me. Thank you.
Hi, my name is HUSNA and I will explain question number 4. So firstly, we need to understand the idea of differentials and we need to know the value of x and x0. Based on the question, we can get the value of x, which is 49.02. After that, to determine the value of x0, we will use x equal to 49 because it is close with 49.02. So the value of x0 is 49. So this is the value of x and x0. Then using the power rule, we need to justify equation for the fx and the f prime x from the equation that given from the question and substitute the value of x0 into both equations. To find the equation of fx is through differentiation. So this is the equation for fx and f prime x. After that, we need to find a delta x, which is a small change in x. Formula to find a small change in x is x minus x0. So substitute the value of x and x0 into the formula and we will get the value of delta x is 0.02. Then we need to determine the function value at the new point using the differential formula. This is the differential formula that we use. Then we need to substitute the value of the fx, f prime x and the delta x into the differential formula. So we can get the answer is 328.20857. Then we need to round the answer to 2 decimal places. So the final answer for this equation is 328.21.